Hey yo, what's crack-a-lackin'? Once again, it's your mans, and right now I'm checking in from beautiful sunny Southern California. It's the beginning of the summer, and I'm out here at one of these mountain peaks out here in northern Los Angeles County. And I decided to biologize this particular area because it does seem quite special right now. There's actually a lot going on here. You know, it's early summer and I'm seeing a lot of activity, at least as far as the insects go and everything. I mean, I don't know if you can tell right now around me, but we have a lot of blooming plants here. I said it's early summer. But basically at these mountain peaks, you know, they kind of have a delayed response when it comes to transitioning from, you know, winter, spring, summer. So, you know, bloom periods can start off a little bit later in the year and everything. But when that bloom does come, it really turns up the activity. And hopefully I'll get to show you a good assemblage of the things that are taking advantage of this bloom right now. So our current position here actually isn't quite too far from the main boundary of the San Andreas Fault, the world famous San Andreas Fault. You know, that big crack in the Earth's crust that basically traverses down the western coast of California, you know, all the way from Baja up to San Francisco and beyond. So over the past, you know, tens of millions of years, there's been a lot of geologic activity going on here. I mean, you can see those mountains in the back. I don't know if you can see that right there, but, you know, we got some layering. So most of all this geography millions of years ago was under the ocean. And that tectonic activity kind of lifted it up, and the tectonic movement from the transverse slip fault system from the San Andreas Fault basically kind of crumbled up and deformed a lot of the rock out here. So I believe that the bedrock formation that I'm standing on right now is a type of sedimentary rock that used to be marine and everything. But, you know, since then, like I said, through tectonic activity, it's been uplifted, and now we're sitting at about 5,700 feet above sea level atop one of these mountain peaks that is basically acting like a sky island. You know, sky islands are essentially mountain peaks, like high up in the sky, and usually these islands, you know, the ecological effect of being on an island system, you kind of have a somewhat of a unique diversity of species assemblages, both plants and animals, that are unique to these particular elevations on these particular mountain peaks. And right now I'm in Southern California on top of one of these mountain peaks, and we're about to see what they got out here. So the vegetation community that I'm standing in right now is what is known as a chaparral. And chaparral systems are biomes that are typically found around temperate latitudes. If you live in a Mediterranean climate, likely you'll have some chaparral areas, especially within the higher elevation inland areas. And usually the dominant types of vegetations are very large shrubs or small trees, however you want to describe it. And it's very thick, very scrubby. You know, there's a reason why they call certain habitats, they use that terminology scrub, because, you know, if you were to walk through it, like straight through this stuff, it will scratch you up. I guess akin to, you know, being scrubbed. And as you can see there by those dead crowns of trees, you know, that's evidence of past fires moving through this area. You know, this area might have been burnt multiple times probably within the last 100 years, I would imagine. I mean, I don't know the complete history of this particular region, but you can see by the presence of these dead crowns from these trees and shrubs and everything that, you know, there was a past fire that had moved through here. And since then, the whole area has been kind of rebounding. So the plant species that's making up the dominant upper canopy, or like the taller canopy within this area, is this right here. This is Quercus berberidifolia, aka the California scrub oak. And it's pretty thick out here. Pretty much a lot of the dark green that you see, even those big trees, actually that might be a different species of oak. But yeah, the dominant vegetation, the dominant high canopy vegetation here is this family Phacelia, which is the oak family, and you can see starting to have a little bit of bud bursts, which will reveal flowers, and those flowers will in turn get pollinated, probably by some sort of insect, and then it'll turn into an acorn. There's no acorns on this right now because it's early in the season, but you can see right here the kind of the cap scar of the acorn that used to be there. This fell out. It might have been pulled off by a bird or a squirrel or stashed somewhere or something like that. Acorns have high protein packed nutrition within them, and, you know, the lineage of oaks kind of co-evolved with certain animal species that, you know, take advantage of using their acorns as a food source, and also dispersing those acorns so they can, you know, sprout and grow up into a new oak somewhere else. But what lives in these oak trees isn't really the interesting thing I was talking about when I was talking about this area being interesting, you know. What's interesting is like what you can kind of see behind me. Yeah, you know, right off this dirt road, you can see like this embankment right here. It's got a lot of colors going on, and that's just because, like I said, you know, it's the early summer out here, which is basically somewhat like late spring up in high elevations. So you got all these flowers popping out, calling to their pollinators to come and get a taste of this sweet nectar so you can take my pollen and go fertilize another plant. So we're going to take a little time and focus on some of these blooming species of plants here and, you know, see how well they are at throwing a nectar party. So the first plant up that I see is garnering a lot of attention is this one right here. So this I know is in the genus Phacelia, and I tried looking it up earlier, and I have a feeling it is Phacelia egena, which I think the common name is Kaweah river Phacelia or something like that. It's either that or mountain Phacelia. Either way, either species, I mean, this is a type of Phacelia that I'm used to seeing in higher elevations, you know, elevations 5,000 feet up and higher and everything. But it kind of has this kind of like scorpioid appearance as it's like popping its flowers. You can see right there, it kind of has like that fiddle neck appearance. And members within the genus Phacelia typically exhibit that type of floral bud burst. Yeah, I mean, you got the newer flowers at the distal end, preceded by older flowers. Okay, and right there we have one of the main pollinators that I'm seeing on this plant. Hopefully I can keep it in frame. But that right there is Bombus vosinski, also known as the yellow-faced bumblebee. As you can see right there, it's got that tuft of hair right on its clypeus, or its, yeah, that tuft of hair right there on its face. I guess that's why it gets the name yellow-faced bumblebee. I could be wrong about this species too. Okay, here we have another species of bumblebee. I cannot tell exactly what this is right now. Maybe if I get enough good footage, I can look it up later to see what it is. So its mouth parts have evolved a tongue-like structure to kind of get in there, get after those nectar sources that this Phacelia has to offer. So it's in the family Apidae, and apids are known to gather pollen on special sacs on their hind tibiae. This one doesn't appear to have any pollen on those sacs right there, so it's kind of a bad example. And whatever species this is, it is a little bigger than Vosnesinski, like at least 1.5 times the size. There are many different species of bumblebee out there, and I can have a hard time identifying them. All right, back to the yellow-faced bumblebee right there, Vosnesinski, and you can see it's got those sacs on its hind tibiae kind of filled with pollen right now. You can see how it just like kind of stuffs its face in that flower, and it used those that tongue-like structure to lap up the nectar that this Phacelia offers. And you can see that those styles kind of poking out, you know, those are the female reproductive portions of the Phacelia. And as it's stuffing its face in there, undoubtedly some of the hairs on its face will get covered in pollen. And as it moves on to another flower, we'll deposit that pollen on those exposed styles. So bumblebees usually live underground. They're like subterranean, and they usually live in kind of like old abandoned rodent burrows and everything. And that's where they'll have their brood, where they will tend to that brood and get it and reassure its survival for the following generation. Okay, so I moved up here on this side of the hill away from the road, because I'm seeing a lot of stuff going on right now. I mean, you can see how colorful this little like kind of open space meadow section that seems to be breaking up the matrix of all this scrub oak chaparral. And yeah, I'm pretty sure you can see all these colors right here, full of all these blooming plants, all calling to their pollinators, ready for that bestiality. Okay, so right here we have the next plant up that's blooming. This is Eriophyllum convertiflorum, also known as the golden yarrow. Family Asteraceae, so the sunflower family, and hopefully to those of you watching this, these flowers perfectly exhibit the sunflower structure, you know, with those outer ray flowers. And then in the middle you have the disc flowers, in which each one of those disc flowers is an individual flower upon its own, so it's a composite. Okay, that coleopteran we got right there, that is Trichoides ornatus, also known as the ornate checkered beetle in the family Claridae, which is the family of checkered beetles. And members of this family, particularly within this species, I mean, you can see right there, it's kind of got that like Batesian mimicry type thing, where it seems to be mimicking some sort of you know, stinging wasp or something like that with that black and red coloration right there. Anyway, fun fact about these things are parasitic as larvae, so they will lay their larvae, particularly within the colony system of megachilids. Megachilids are a type of bee in the Hymenoptera, ants, bees, and wasps and everything. And those larvae will feed on the pollen and the nectar that the megachilids bring back to feed their babies. So, you know, it parasitizes the food source within those colonies. And then when they become adults, they're actually really attracted to yellow flowers, and they'll spend a lot of their time hanging around yellow flowers and doing what they're doing, as you see before you, kind of taking advantage of the nectar sources of those flowers. And I'm not sure, but I think it does actually help in pollination. And if you ever observe the behavior of this species, you'll notice that it actually does kind of fly around like a fly or a wasp and everything. For it being a beetle, it actually has a decent controllability of its flight. You know, in my opinion, and a lot of entomologists' opinions, beetles are kind of like horrible flyers. You know, like I don't know if you've seen a lot of beetles flying around. They kind of hit you in the face, you know, run into windows and stuff like that. Not these guys though. And this species seems to like it on this yarrow, on this Eriophyllum right here. You know, again with that aposematic coloration, that mimicry coloration, mimicking probably some stinging wasp, some vespid of some sort. And these aren't the only species of beetles that do this. There are a number of species of beetle that do this. I know there's a cerambycid, a longhorn beetle, that also has that type of coloration. Not just beetles too, dipterans, you know, flies. A lot of syrphids, a lot of flies in the family Syrphidae also have this type of coloration and kind of hover around like stinging wasps. Yeah, cool little bug. Oh, hey, you know, speaking of parasites, we don't have animals that are just parasites. We have plants that are parasites too. So this stringy looking orange stuff right here, the common name of this stuff is called dodder, but it is in the genus Cuscuta. And they used to be in their own family, Cuscutaceae, I think. But, you know, due to new research and everything, they found out that it is closely related to the morning glories, or the Convolvulaceae family. And yeah, like I said, it's a parasitic plant. And you can tell it's parasitic because it doesn't have any chlorophyll. It really has abandoned the need to take energy from the sun to produce its own sugars. And rather, it has evolved a parasitic lifestyle. It will insert their tissue into the openings of other plants, you know, i.e. the stomata and everything, and basically steal the sugars and other nutrients from its host plants. And from what I understand, Cuscuta can use a variety of host plants and everything. I was in Australia and I saw another organism, another parasitic plant organism that looks very similar, at least kind of has a superficially similar, you know, kind of look to it, but you know, in a totally unrelated family. It's actually related to laurels, which the only laurels I know of are like tree-like plants and everything. It was kind of cool just to see, like, you know, an example of convergent evolution like that within plants. But yeah, Cuscuta, parasitic plant out here in the Chaparral systems of Southern California. And right here we have an example of what I think is my favorite genus of flowers in California, probably all of North America. But yeah, this is Calicortis, and I think this is Calicortis venustus, also known as the butterfly Mariposa lily. Calicortis is the genus of all Mariposa lilies. Mariposa lilies, globe lilies, yeah, they're in the family Liliaceae, which is the, you know, family of lilies and everything. And my impression of these, as far as their reproductive strategy goes, when it comes to using insect pollinators, I think you can see right there those hairs that are kind of like on the inner portion of that calyx. I think that's what it's called. On the inner portion of that flower, those are guiding hairs, which would guide the would-be pollinator down into the nectar reserves, which are near the bottom. And then you can see those stamens that are those structures kind of pushed out like radially to the side. Those are filled with pollen, so as they're dropping down to get that nectar, they'll be covered in pollen. And when they come and crawl or fly themselves out, that little stigma or style in the middle there, that little like 3-lobe thing, yeah, pollen would then be deposited on that, where it starts the process of fertilization, and then the flower begins turning itself into a fruit. Almost every time there is usually some sort of insect in there. So I think this species is actually kind of a generalist when it comes to like the preferred pollinators and everything. And it really doesn't matter like what kind of goes in there, as long as it's a bug and as long as it kind of, rummages and ruffles around in there, spreading the pollen and then going to, other flowers and, distributing the pollen there. I don't know if you can see in this flower, like way at the bottom there, we have another coleopteran. And that coleopteran looks like it's in the family Monardellidae. And Monardellidae is the family of tumbling flower beetles. There's a better shot of that Monardellid. So I think this is in the genus Monardella. So Monardellidae is the family of tumbling flower beetles. And they're called tumbling flower beetles because of an escape response that they can do with that elongated abdomen. But yeah, obviously you can see it's there feeding on the nectar of this flower and maybe aiding in the pollination of this species. Oh, and in this one, it seems to be we have some sort of cerambycid. I thought this was a species I've seen before in the genus Strophiona, but I think this is a different species. Yeah, I think this is a different species. Strophiona, at least the ones I'm used to seeing, don't really look like this. You can see it right there, digging its face into those nectar resources that this Calicortus has to offer. And right next to these lovely Calicortus, we have another lovely species and family of plant right there before you. I believe we have Monardella breweri, which is kind of somewhat of a higher elevation Monardella, which kind of makes sense. We are up in higher elevation above like 5,000 feet, almost 6,000 feet. I guess this species could also be Monardella villosa, otherwise known as coyote mint, but I don't know. I'm looking at the leaf structures and it doesn't quite scream villosa to me. So I'm just going to call this breweri. I'm well aware that I could be wrong on these things. So if any of you watching happen to be expert botanists and everything like that, and you want to correct me, feel free to correct me. I don't care. I need to be corrected. Family Lamiaceae, which is the family of mints. And oh yes, it smells very good. Very, very delightful. Very delightful. Not too strong of a mint scent, but just right enough. Yeah, if you're doing a long hike out in this habitat and you're just looking for something to boost your morale, just kind of rub your fingers on these leaves and smell them. Oh yeah, sure enough to brighten up your day. But anyway, just like the other species of flowering plant that we were looking at earlier, this one seems to be attracting a lot of flying insects as well. All right, we're going to use the net on this one. And yes, we do have it. Okay, what we have right here is Helioptes erysitorum, also known as the white skipper in the family Hesperiidae. And many Hesperiids will hold their wings like this particular one is holding them right now. Other species can hold their wings in a way that at least some researchers have concluded aids in thermal regulation. And you can see it can kind of do, this one can kind of do the same thing as it separates, so, in resting position, it can kind of separate those hind and fore wings and everything. But yeah, it's a skipper, and they're called skippers because, I guess early observers, when they looked at these, observed them like, skipping along the vegetation, along the blooming flower patches. So I read that the larvae of these actually feed on plants within the family Malvaceae, or the cotton family. Yeah, Helioptes erysitorum, the white skipper, out here in the high top mountains of Los Angeles County. All right, we got another butterfly species on this Monardella I feel is worth talking about. Let's see if I can get it. And we got it. Okay, so this Lepidopteran we got right here, I think this is Argynnis callippi. Common name is the Callippi fritillary. And I don't really see too many fritillaries in California. Actually, I guess what I'm trying to say is I'm not used to seeing that many fritillaries. Yeah, the fritillary species I'm mostly used to seeing is the Gulf fritillary in the genus Agralis, which is actually an introduced species, I think, from the eastern U.S. that has made a home in Southern California. It can be found around urban areas. Anyway, this one right here seems to like exploiting the resources out here provided by the flowering plants in this meadow. Family Nymphalidae, or the family of brush-footed butterflies. And they're called brush-footed butterflies because on the tips of their tibia, they have these brush-like structures, which supposedly is there to actually aid in pollination when it's browsing amongst flowers. You know, it's using its feet to like kind of grab onto the flowers, and in turn, the hairs or the hairs or the brush, so to speak, on its feet will pick up pollen, and as it uses those feet to land on another flower, it will then, you know, have the chance to deposit some of that pollen onto the female parts of the flower. Yeah, nice. Our genus Callippi, Callippi fritillary. Don't see these too often. And of course, it wouldn't be a flower meadow without this introduced species, Apis mellifera, family Apidae, European honeybee, if you don't know the common name already. Classic introduced competitor species to all the native bees out here in North America, introduced from Europe. Okay, right here, also feeding on the nectar of this Monardella, we have a member of the Diptera, or the true fly order, in the family Bombyliidae, which is the family of what's known as bee flies or bee mimicking flies. Not really based on how they look, but on what they do. But yeah, this is Heterostylum. At least I think it's Heterostylum. I can kind of see. I mean, Heterostylum, behind the eye, they have this like little notch towards the rear of their eye. And I think this is Heterostylum. If it's not, then hopefully I'll be able to identify it later. You can see right there it has those adapted mouth parts that have evolutionary formed into this proboscis-like structure, which is very good at getting into those nectar reserves that this Monardella has. Oh, and then right there, I mean, in an area full of all these herbivores, it kind of makes sense. Well, let me get a better shot. There we go. We got a little predator, a little salticid. And I'm not sure what species this is, but you can see this salticid right here hanging out on the Monardella as well, hoping to catch a tasty morsel. I'm just sitting on this flower, hoping to catch a tasty morsel of suitable size, obviously, of some sort of a unlucky pollinator coming to this Monardella to eat. And then it's going to find out that it's going to get eaten by this little predatory salticid right here. Alright, so I guess that about does it for me over here on this Sky Island section out in the mountains of Los Angeles County. We saw a lot of stuff here. Very good species richness of plants, of flowering plants specifically. Very, very good species richness of insects and pollinating insects, arthropods in general. I mean, we saw nymphalid butterflies, hesperiid butterflies, apid bees, you know, other hymenopterans, other ones I didn't even get to talk about today, halictids, other species of apid. We had many different species of beetles that act like pollinators, even a beetle species that's known to be parasitic on hymenopterans. And also there's parasitic species of plant here too. You know, all these plants out here all in the same spot, taking advantage of this open space in between the scrub oak chaparral on this mountaintop, basically kind of kicking it into gear right now as the season transitions into summer. All the flowers are blooming, basically acting as signs saying, hey, come here pollinators, come get some of this juicy nectar, and in turn you're going to help me reproduce. There's a whole lot that I saw that I didn't get a chance to discuss with you today. I mean, there's at least a handful of families of insects that I didn't even get a chance to talk about because it was hard to film them, to be honest. But you know, we saw a lot, a bunch of representations of different species representing different families. Very good spot, very, very, very good spot. And it seems to be like a very true diversity here when it comes to the plants and the animals, particularly the arthropods. But once again, thank you for watching. And remember, keep your decisions scientific, stay away from all the gimmicks. I'll make about slice. Peace up, peace out, learn some.